Okay, so this is an introduction to inverses. So basically, inverses are all about opposites. So if I were to ask you some number plus 5 equals 15, you would say that that number is 10. And you would know that because how we solve an equation is by using inverse operations. So if I subtract 5 from both sides, that's how I'm getting 10. If I say some number divided by 2 equals 20, you would say that number is 40 because you're doing the inverse. You're doubling 20 to get 40. So inverses are all about opposites. So to find an inverse algebraically of a function, we have two main steps. Step 1 is to switch the x and the y variables, and step 2 is to solve for y. So you don't see a y in number 1 because f of x is the same thing as y. So I'm just going to write this as y equals x over 7, and now I get to do my step 1. So my step 1 is to switch the x with the y. Now my step 2 is I'm going to solve for y. So what I do is I do the inverse operations. I see divide by 7, so I multiply by 7 on both sides. My 7's cancel because 7 divided by 7 is 1. And now I have that y is equal to 7x. Now I don't just write y because this y and this y are different y's. You'll see when I graph it, they're not the same. So I put this little -1 up here in the corner to indicate that that's the inverse. So an inverse is kind of like a cousin. Like they're related, they have some things in common, like they both have a 7 and they have an x, but they're a little bit different because this one has division and this one has multiplication. So what does y equals 7x look like? Well, I have my graphing calculator right here, and I can type in y equals 7x, and I see I have a pretty steep line. It's going to have the point 1 comma 7. And I have 0, 0, obviously. And then I'll have -1, -7 on there. And my bad with this graph. I really didn't give you enough room to do that. But it actually works out the same if I just count the boxes. So if I go up 7 over 1, 1, 2, 3, 4, 5, 6, 7 over 1. I have the origin, and then I go down 7, 1, 2, 3, 4, 5, 6, 7, over here 1, and I'm going to do my best to connect it, and this is not an art class, so just bear, it's not the prettiest. So that's what the inverse looks like. How are these lines related? Well, they have opposites here. So if I have the point 1, 7 here, sorry, I don't know why that's so thick. I also have the point on this one, 7, 1. I have the opposites. It's always like that. Every point's opposite, like switching the x and the y, will be on the other graph. Pretty fun. Okay, one other thing that happens on the graph always, always, always is this line of symmetry. So if I take this line that goes straight up the middle through the origin, this is the line of symmetry for, or the line of reflection for these graphs. So if I were to take my paper and fold it right along that blue line, my two lines will be on top of each other. It spreads out from that line of reflection in both directions equally. So it goes down just as much as it goes up. And that line will apply for every single thing that we do. So let's go over here. Step 1 is I'm going to switch the x with the y. Well, I don't have a y yet, so I've got to put it there. And now I switch them. X equals 3y plus 5. Whoa. Ah, that was crazy. Y. Sorry, let me fix my 5 here. So inverse operations, remember. So the first thing that we have to do is we have to subtract 5 from both sides because positive 5 and minus 5 are opposites. They're inverse operations. They cancel out to 0. And we're left with x minus 5 equals 3y. Now to finish getting y by itself, isolating the 5, or the y, we're going to divide both sides by 3. So I have y is equal to x minus 5 over 3. Now remember, this y that I have in this dark green color and this y that I have in this blue color are not the same y. They're inverses of each other. They're cousins. So there's my y to the negative 1 power. And we call that y inverse. Okay, that's how we indicate that we have an inverse. So I need to differentiate between this light blue and this green because they're not the same y. You'll see when I graph it that they are related to each other. They're inverses, they're opposites, but they're not the same. So when I look at the graph of 3x plus 5 that's already here, look, I have a y-intercept of 5. I have a y-intercept of 0, 5. Remember opposites. Watch what happens when I go and put that inverse into Desmos. When I put that inverse into Desmos, it's x minus 3 over 5. Is that what it was? No, it's x minus 5 over 3. Okay, look, I have an x-intercept at 5. So one of them has a y-intercept at 5. Super awesome. So if I go ahead and graph that, again, I really messed up on these graphs. So this should be like, it goes, oh shoot, it goes by 2s. So this would be, like 4, this would be 6. So there's my x-intercept of 5. So let's see what else we got here. I have, oh, that's not fun to graph. So let's see what I have. -1, -2 is another good point on my graph. -1, -2. So I can graph that. -1, -2 is right there. And that shouldn't be a surprise because -2, -1 is on my other graph. They're total opposites. -2, -1, and -1, -2. So there's my graph. And again, it's not an art class. This is supposed to go through there, but trying my best over here. And if I add in that line that goes straight through the origin diagonally with a slope of 1, I see that it opens up just as much as it opens down. It's almost like an angle bisector. If you've taken geometry, you'll know what I'm talking about. Okay, we're not going to do number 4 right now, but I'm going to look at number 3. So again, step 1 is I'm going to switch the x with the y. So switch the x with the y. All right, there's my y. Now I need to start solving for y. So I am going to add 3 to both sides. So I have x plus 3 is equal to 2/3 y. Now to inverse 2/3, it's 3 over 2. So my 2's will cancel, my 3's will cancel. So I'm multiplying both sides by 3 over 2. So my inverse is 3 over 2 times x plus 3. So let's go see what that looks like graphically. So I have y equals 3 over 2 times x plus 3. I have a y-intercept of 4.5 and an x-intercept of -3. Those two things are very helpful for when I'm graphing. So that shouldn't be a surprise since we have an x-intercept of 4.5 here. I'm going to have a y-intercept of 4.5 up here. They always switch. Then I had a y-intercept of -3, so that's going to give me an x-intercept of -3 over here. on my other line. Ooh, not the best line. Okay, so now I'm just going to draw that line of symmetry in here, that line of reflection. And eventually these lines would cross down here because they're not parallel. But again, you can see that as much as I go up is as much as I go out here. See this kind of distance that's equal. That's an inverse.